Hey everyone, Mr. Houck here. In today's video, we're going to go over the answers to the probability test review with all work shown. All right, so let's go ahead and get started. Number one here, determine if the following event is independent or dependent, then calculate the probability of the event occurring. So we want to figure out what is the probability of getting 2 blue candies without replacement from a bag of 7 red candies and 5 blue candies. So first order of business, determine if the event is independent or dependent. Key phrase here, without replacement from a bag. So we are not replacing the candies. That means this is a dependent event. Let's go ahead and get rid of answer choice A and answer choice C. Now we want to go ahead and find the probability of this event occurring. So let's figure out our total first. We have a bag of 7 red candies and 5 blue candies. 7 plus 5, our total of candies is 12 in this bag. First time we draw from the bag, we're trying to get blue candies here, 2 blue candies in a row. So the first time we draw from this bag, we have a 5 in 12 chance of pulling out a blue. We are not replacing it, so the second chance we pull from this bag, there are only 11 candies remaining. We've already taken one of the 5 blue candies away, so now there's only 4 of the 5 blue candies remaining. And this is going to give us, let's go ahead and pull up good old Desmos. Let's get our percent chance of this happening. All right, 5 out of 12 times 4 over 11.515. 0.1515 rather, 0.1515 or 15.15%. There's our answer. That would be answer choice B. We'll just leave the calculator there. All right, problem 2. You're designing a standardized test to replace the dreaded SAT and ACT. There will be 6 sections to your new test. You have 3 options for the topic of the first section, 4 options for the topic of the second section, and 2 options for the topics of the remaining sections. How many different standardized tests can you make? So one of the things that I know some people might have a hard time with this unit doing is knowing when to use what. Like, how do I know if it's a combination problem? How do I know if it's permutation? How do I know if it's fundamental counting principle? How do I know when I'm doing binomial probability? You know, all the different topics we've looked at. Some people have a hard time telling when do I use what. So it's saying here, how many different standardized tests? That phrase right there, how many different? So it's not a probability. We're not setting up fractions or ratios or anything like that. So now you need to figure out, okay, well, is this a fundamental counting principle problem? Is it a permutation, a combination? But notice it's not saying like, how many ways out of 30 people could I organize or get 5 of them? It's not giving you an out of this many total. So this is going to be a fundamental counting principle problem. So let's go ahead and just set up that fundamental counting principle problem. So there's going to be 6 sections on this test. That means there are 6 things that we're going to multiply together. You have 3 options for the topic of the first section. So 3 options for the first section, 4 options for the topic of the second section, and then 2 options for the topics of all the remaining sections. And that's going to be 3 times 4 times 2 times 2 times 2 times 2, which is 192. And there's our answer choice B. All right, problem 3. A group of 20 students are all racing together. How many different ways can they get first and second place? So immediately when you see, you know, how many different ways, and we're talking about placement, first and second place, vice president, co-president, or president, vice president, or, you know, something that indicates that order is important, that the order matters, we're talking about a permutation. So here, the order matters because of first and second place. We're talking about specific placement. And because the order matters, we're talking about a permutation. Permutation, order matters. Combination, order does not matter. All right, so we're talking about a permutation here. We have 20 students, that's our total, and we're trying to find out all the different ways we can get first and second place. So this is 20 P2. Remember that if you're using Desmos, click on your Functions tab, scroll all the way to the bottom. At the bottom, you'll see NPR and NCR. Obviously, take NPR for permutation. 20 first, that's the N. Then comma, don't forget the comma. 20 comma 2, that's 380. So there are 380 ways from these 20 students that are all racing together that we can get first and second place. All right, problem 4. Let me highlight this one just for consistency. There we go. All right, problem number 4. A habitat is filled with 15 large and fluffy pandas. 4 of them need to be moved to a new habitat. How many ways can a zoologist choose 4 pandas to take this new habitat? So nothing here really indicates that order matters. They're just taking 4 out of these 15. There's nothing special about which 4 get selected. There's no order placement that matters here. So order does not matter. Order does not matter. And because order does not matter, this is a combination. Okay, combination, not a permutation. So we have 15 large and fluffy pandas. We are choosing 4 of them to be moved. 15C4. So same deal, come over here to Desmos, hit the Functions tab, all the way to the bottom, this time in CR for combination. 15 is in, that's the total group that we're taking from. We are choosing 4 of them, 1,365. Answer choice A there. All right, problem number 5 now. So, variety bag of chips is shown in the picture. If I grab 15 bags of chips at random, what is the probability that I got 2 Cheetos, 2 Lays, and a bag of Ruffles? So this is one of those problems that we saw many examples of these, where we have a certain amount total, but we're trying to target multiple outcomes. So we're trying to specifically target 2 Cheetos, 2 Lays, and 1 Ruffles. And we can see from the image here that there are 18 bags total. Right here. Okay. 18 bags total. They tell us how many Lays are in this mix, how many Doritos, the red ones, blue Doritos, Cool Ranch ones, 4 Cheetos, 2 Ruffles, 3 Fritos. Okay. So here, to set this up, and by the way, it doesn't look like order matters here. I'm going to go and note that. Order does not matter. There's nothing to do with placement or anything like that. Order does not matter. So we'll be dealing with combinations, not permutations. But remember that when we set up these probabilities here, we would always put the number of total outcomes in the denominator. So we know we have 18 bags total. We are choosing 2 plus 2 plus 1, 2 Cheetos, 2 Lays, 1 Ruffles. So we're choosing 5 bags of chips. 18C5. Then in the top, we're going to look at specifically what we're trying to target. So of the, we're looking at 2 Cheetos here. Well, there's 4 Cheetos. See that right there. So of the 4 Cheetos, we're choosing 2. Of the 3 Lays, we want 2. So 3C2 for the Lays. And of the 2 Ruffles, we want 1. 2C1 for the Ruffles. So these are all this is how we set up all the different things we're trying to target here. We're specifically targeting, again, 2 Cheetos, 2 Lays, and a bag of Ruffles. Now, in Desmos, I know that when we took the probability quiz, it didn't let us enter the entire, there was something weird about the Desmos graphing calculator that was embedded into that SchoolNet quiz. So when you run into a situation like that, let's just go ahead and assume that maybe the Desmos calculator on the test here isn't going to let you enter in the entire fraction. So let's enter in the numerator separately. So 4C2 and CR 4, 2 times NCR again 3C2 3, 2 times all the way again NCR 2C1 2, 1. we get 36. Denominator, 18C5. Do this separately. 18, comma 5, 8,568. And then let's just divide the two. 36 divided by 8,568 is 0.0042. 0.0042. Our answer choices are all in percentages, so this is 0.42%. Which is answer choice. No, that should be. So this was a typo, by the way. I don't know if it went online when you took the practice test. This might have already been fixed. Should be 0.42%. So this is our correct answer right there. All right, problem 6. You are playing a game involving a 20-sided die. The rules are as follows. Rolling an odd number wins you $1. Rolling an even number below 10 wins you $2. Rolling an even number above 10 loses you $3. And rolling a 10 loses you $10, loses you a lot of money. So we want to know, what is the expected value of playing this game? So expected value. We want to think about what is involved with expected value problems. So expected value problems are where you find the probabilities of all these different events happening, and you multiply them by the value of that event happening, and you add all those values times probabilities, you add them all together. That gives you the expected value of that, of that event, of playing that game, so to speak. Okay? So let's go ahead and make a table or a chart that shows how all this stuff is going to be put together. So I'm going to make a 4-column chart. Let's get the straight edge tool. There we go. All right, I'm going to have the event, the value of the event, the probability of that event, and we'll just call it x times p of x, the value times the probability. All right, so the events that can happen. Rolling an odd number. So event 1, we'll just call it odd number. Event 2, rolling an even number below 10. So I'll just say even, put some space here. Even less than 10. We could have roll an even number above 10. So even greater than 10. Or we could just roll a 10 outright. A 10, okay? So if we roll an odd number, we get $1, positive $1, positive value here. If we roll an even number below 10, we win $2. Another positive outcome, positive $2. If we get an even number above 10, we lose $3, negative $3. And let me just be consistent with dollar notation. Usually go to 2 decimal places when we're talking about money. And rolling a 10 loses you $10, so negative $10. All right, the probabilities of these things happening, so it doesn't say it right here, but we have enough information to figure it out. We're talking about a 20-sided die. So what's the probability of rolling an odd number on a 20-sided die? Well, that's 50% chance. 10 out of 20 are going to be odd numbers, or 50% chance. We'll just go ahead and say 10 out of 20. What is the probability of rolling an even number less than 10? So 10 cannot be included. That'd be 2, 4, 6, and 8. That's 4 out of the 20. Rolling an even number bigger than 10. Again, 10 does not get counted. 12, 14, 16, 18, and 20 itself. That's 5 out of the 20. And rolling a 10, well, it's a 20-sided die. Only one of the sides is going to have the number 10 on it. That would be 1 out of the 20. And then we do x times p of x. So the value, each of these values, times the probability of that thing happening. A positive $1 value times 10 out of 20. A positive $2 value times 4 out of 20, so on and so forth. So let's go ahead and calculate these probabilities. 10 out of 20 is just half. So $1 multiplied by half, that's going to be 0.5. $2, 2 times 4 out of 20. Let's just go ahead and put the whole thing in the calculator. So 0.4 negative 3 times 5 out of 20. That's going to be negative 0.75. And then negative 10 times 1 out of 20. Negative 0.5. All right, so the expected value is we're going to take all of these values right here, we're going to add them all together. So 0.5 plus 0.4 minus 0.75 minus 0.5, and that gets negative 0.35. All right, we're talking about in terms of money here, so we are losing on average 35 cents every time you play the game. So we are not expected to win because our value is negative. We are losing on average 35 cents every time we play. Answer choice C. All right, problem 7. You are flipping a coin 8 times. What is the probability that you get tails less than 2 times here? So flipping a coin, there's only two outcomes, right? You flip a coin, if you get tails, we'll consider that a success. You flip the coin, you get heads, we'll consider that a failure. We can calculate this using binomial probability. Now it says here, you're flipping the coin 8 times. What's the probability you get tails less than 2 times? Strictly less than, not less than or equal to, strictly less than 2 times. This means 0 times or just 1 time. Okay, so what we're going to do is we're going to calculate the probability of flipping tails 0 times, the probability of flipping tails 1 time. We're going to add those probabilities together, and we're going to use the binomial probability equation or formula to get those calculations. So it's going to be on your formula sheet, but we are looking at NCR times P to the R power times Q to the N minus R power. I believe that's the formula there. Where remember that N is just representing, in our case here, N is going to be the 8 coin flips. R is going to be 0 and 1 for the 2 different calculations that we make. P is the probability of success. Well, you're flipping a fair coin. So the chance that you land on tails is 50%. Q is going to be the probability of failure. Well, again, you're flipping a coin. Probability that you don't land on tails is going to be 50% chance. So 50% chance for P and Q. To the R power, so you're raising P to the number of successes. R is going to stand for the successes we're targeting. And N minus R would be the number of failures. So let's go ahead and calculate these. So first we're going to look at the probability of getting tails 0 times. So it's going to be 8C0 times 0.5. P is 0.5. Let's go ahead and write these values over here. N equals 8. R, we're going to calculate for 0 and 1. P, probability of success, 0.5. Q, probability of failure, 0.5. So 8C0 times 0.5 to the, what we're expecting to flip tails, we're targeting flipping tails 0 times, times the probability of failure. Well, if we flip tails 0 times, that means we flipped heads or failed 8 times. Let's go ahead and calculate this. So NCR, go down to the bottom, 8, 0, times 0.5 to the 0 power, times 0.5 to the 8th power. That's going to give us 0.0039. Okay, now we need to do the same thing, but for flipping tails 1 time. So now 8C1 times 0.5, we're going to be successful 1 time. We're going to fail flipping tails the other 7 times. So let's just change some of these numbers around. Change that 0 to a 1. Change this exponent to a 1. Change this exponent to a 7. That's going to get us 0.03125. All right, let's add these two together right here. 0.0039 plus 0.03125, and we get 0.03515. Right, there's our answer. Oh, come on, auto shape, we can do this. And I'm missing a 0. There you go, 0.03515. And that'll be answer choice B. We just rounded it a little different. Or it's a rounded version of our answer. 0.03515 or 0.0352. All right, almost done. Last page of our review, problem 8. So problem 8 here. A survey was conducted regarding how many movies were watched each month. The results are posted below. 0 movies, 31 people watched 0 movies, 38 people watched 1 movie, so on and so forth. Given the above probability distribution, what is the expected value of a movie, or the expected value of movies a random person has watched each month? So again, another expected value problem. You see that phrase there, expected value. Let's go ahead and make a table, very similar to the one that we just made, 4-column table. All right, in our first column, the event, the value of that event. Really, honestly, I don't think we need to make a 4-column table because the event and the value of the event is going to be the same thing in this case. So let's make a 3-column table here. Yeah, this should be fine. The probability, you'll see what I mean by that when we make the calculation. And then x times v of x. So someone watches 0 movies, 1 movie, 2 movies, 3, and 4 movies. Let's go ahead and get our total. So it's a telesurvey was conducted, blah, blah, blah. Let's add up all these numbers together, get our total. 31 plus 38 plus 21 plus 7 plus 3. 100 people. Nice number there. Total 100 people. All right. So the probability that, someone watched 0 movies, 31 out of 100, or 0.31. Probability that someone watched 1 movie, 38 people, 38 out of 100, 0.38. Someone watched 2 movies, 21 people, 0.21. 3 movies, 7 people, 0.07, 7 out of 100. And then 4 movies, 3 out of 100, 0.03. So the value that we're looking for here, we're looking for what's the expected value for the number of movies a random person has watched. So the event is doubling as the value here. Okay, that's what we're trying to calculate the expected value of. So 31% chance you watch 0 movies, 0 times 0.31, that's going to be 0. Let's go ahead and add all these up together. E of x here, let's just do this all on the table. 0 times 0.31, that's 0. 1 times 0.38, so the probability, 38% chance that you watch 1 movie, or 38% chance that someone watched only 1 movie, that's 0.38. 0.21 times 2, 0.42. 0.07 times 3, 0.21, and 0.03 times 4, 0.12. Add these all together. E of x, expected value, equals 0.38 plus 0.42 plus 0.21 plus 0.12. So 1.12. And there was probably something that went on with some kind of rounding there. Answer choice 1.13. That's by far our closest, just right there. Next. Last problem, you are playing a spinner game with a spinner pictured. It costs $2.50 to play the spinner game. If you land on a red space, you lose $1. If you land on a blue space, you lose $2. If you land on a green space, you win $3. If you land on a yellow space, you win $5. What's the expected payoff of playing this game, and should you play it? So, expected payoff. Very similar to expected value, but here you're putting money in to play the game, okay? So we want to be aware of that fact when we calculate our values. But let's go ahead and make that kind of typical, 4-column table here. So we have an event. We have the value of an event happening, the probability of it happening, that value times the probability. Okay, so let's see. You can land on a red space. There's one event. We can land on a blue space, green space, and a yellow space. If we land on a red space, it tells us we lose $1, but we also paid $2.50 just to play the game. So really, if you land on a red space, not only are you paying $2.50 to play the game, but then you lose another $1. You pay another $1 if you land on it. So the value of landing on a red space is negative $3.50. If we land on a blue space, we're told that we lose $2, but we already paid $2.50 to play, so we're really losing $4.50 if we land on a blue space. If we land on green, you win $3, but you paid $2.50 already, so you're really only positive 50 cents. And if we land on a yellow space, you win $5, but you paid $2.50, so you're positive $2.50. Okay, so when you're doing these expected payoff problems, if you're putting money into the game that you're playing, or whatever, if you're putting money into this event, you got to take that into account with the value. All right, probability of this stuff happening. Well, if we look over here, if you look at the spinner that they gave us, 3 out of the 8 spaces are red. So probability of landing on red, 3 out of 8. 2 out of the 8 for blue. 2 out of the 8 for green. 1 out of the 8 for yellow. Now let's go ahead and multiply the values times their probabilities. So negative $3.50 times 3 out of 8. That's negative 1.3125. Negative $4.50 times 2 out of 8. Not 2 divided by 8. Negative 1.125. Positive 50 cents times 2 out of 8. 0.125. And then finally, $2.50 times 1/8. 0.3125. Let's add them all up and be done. Negative 1.125 plus 0.125 plus 0.3125. You get negative 2. Negative $2. Every time you play this game, you're expected to lose $2. So should you play the game? No, because you're expected to lose money, and specifically, you are losing $2. Answer choice D. All right, so that's going to be the probability test review, and I hope you guys do very well on it.